More on expansion. I have here 2 pieces of glass rod, so it looks. 2 pieces of glass rod. I assert, however, that one of them is glass and the other is quartz, and I'm going to heat them in this flame. And I want to show you a very remarkable thing. I'm heating them both, the glass and the quartz. I'm going to heat them until they get red hot, and remember, color is a thermometric property. And then I'm going to immerse them while red hot in a beaker of ice water. And what would you expect? Would you not expect them to shatter? Let's assume they are heated enough. I see some yellow flame there, which is characteristic of sodium glass. Watch it now. Now let... I call to your attention the fact that they have both shattered. Whereupon I say as follows. I made a little mistake. I thought one was quartz and the other was glass. So you see what experiment in the laboratory means? Sometimes things go as you wish and sometimes they do not. But what I wanted to show you is this. The glass one would indeed have shattered into 1,000,000 bits. Here, I'm going to show you that. Watch, watch. Oh, look at that. Oh, look, see, 1,000,000 little bits. But the quartz one would not, because quartz has a very low coefficient of expansion. Now, here is another demonstration which you can do for yourself. Here is a metal rod, and here is a little L-shaped wire which marks against a certain scale if we can get tight on it. Now I am going to... Oh, no, I thought my flame went out. No, I'm going to heat that. I'm going to heat that. And if we can see the scale right tight, at right angles to it, I hope you can see. I'm sorry, we had a little disaster. I turned on the gas too much. Do you see the adventures which can come when we do experiments in the lab? No hurt. The hose just blew off. This is experiment. Consider another. Here is a long rod. Aluminum. Here it rests against a registering meter, and I am going to heat this rod. If we can get a view of this scale here, very closely, it reads 0 to begin with. I'm in a little trouble because I don't have my heat source. I detect a slight change in the length of this rod. Ever so slight, but nevertheless it exists. So I have an interesting little question for you. A wonderful question. Consider a railroad rail that runs, let us say, from Los Angeles to San Francisco. That's about 400 miles. A steel rail. Supposing that was one rail, and supposing we assume that between the coldest or lowest temperature and the highest change in temperature, we might have 25 degrees change in temperature between the lowest and the hottest in the course, say, of a night. Question, how much do you think that steel rail would expand? 400 miles of it. Now, you know the steel rails are laid so that there is a little gap between successive ones. That little gap is very small indeed. But here is something for you to calculate. The steel rail, one rail, between Los Angeles and San Francisco being 400 miles long, suffering the change in temperature I have suggested, would expand, what do you think, a foot, 10 feet, 50 feet? No, I'm going to tell you, 600 feet. 600 feet. Isn't that fantastic? So those little gaps between the successive rail lengths between here and San Francisco, those little gaps add up to 600 feet. That's absolutely astonishing. More about expansion. A wonderful thing. How many of you have seen popcorn? Everybody in the world has seen popcorn. Here is some popcorn. Now you know what you do. You apply some heat to the popcorn, to the dry, lifeless, dead, inert popcorn. But I would remind you, It is not dead, lifeless, and inert. If this is put in the good earth, and it has the right change in temperature, the right dark and the right light, the right heat and the right cold, the right wet and the right dry, it will sprout and beget itself millions of fold. So it is not lifeless. I ask, when I heat that and the corn pops, why does it pop? Why does it burst so big and beautiful? Answer, there is, however dry it is, there is some water in it, ever so slight a bit. And when that water is heated to the state of steam, it expands 1,700 times. That is, if I have a little droplet of water in there, so big, when I heat it to steam, it is 1,700 times bigger. And I say that's fantastic. One final little inquiry, which you can do yourself. Here is a flask which is filled with colored water and with a one-hole stopper and a glass tube, and you see the level of the water to this place here. Now, you know that if I mechanically squeeze the wall of the flask, the level goes up. If I mechanically squeeze the small edges of the flask, the level goes down. Down, up. Question. Supposing I heated the walls of the flask, heated them, would the level go up or would it go down? And so I have left you with a number of exciting and dramatic and stirring inquiries concerning the expansion of stuff. And I thank you for listening.